Hello, fellow kids. Today we are going to derive the formula 1/2 mv squared and talk about the work energy theorem, which says that work is equal to change in kinetic energy, which is how we're going to get the formula. So, I'm going to assume you are at least somewhat comfortable with what an integral, what it means. So anyways, with the equation, work is equal to the integral of force with respect to displacement. Hopefully you understand what that means. It doesn't matter if it says dx or dr in your equation sheet, it means the same thing, an infinitesimally small change in displacement. But anyways, we can rewrite force, right, as ma because of Newton's second law, so we'll do that first. Equals the integral of mass times acceleration, dx. And since mass is a constant, actually, we can take mass out of the integral. Mass out of the integral. We could technically do this later, but I might as well just do this now. You can actually rewrite acceleration as the derivative of velocity with respect to time, right? So let's do that. Equals m times the integral of dv over dt, derivative velocity with respect to time, times dx. But wait, if you multiply dx times this fraction over here, you can group dx and dt, and that's equal to velocity, right? Derivative of position with respect to time. So this is going to equal m times the integral of v dv. Now, if we want to take a definite integral, right? You're gonna integrate from your initial velocity to your final velocity. And if you evaluate this integral, right? This integral equals, for just the function, it's v squared over 2, or 1/2 v squared. And we are going to evaluate it from final velocity to initial velocity. So if you evaluate this here, you get mass times final velocity squared over 2 minus the initial velocity squared over 2. And notice you can actually factor out the 1/2 here, huh? So you get 1/2 m, and what you're left with is delta v squared, right? Vf minus v initial, that's delta v squared. Then you get 1/2 m delta v squared. And if your initial velocity is 0, and you're only given one velocity, then the change in velocity is just equal to your velocity, and you have 1/2 mv squared. So there you go.